The experiment is to investigate motion in one direction. Part A. We are going to investigate constant velocity. For this experiment, you will need a rail track, a dynamics trolley, a ticker timer, ticker tape, piece of round carbon paper, a tape measure, a suitable support such as a can, a 12-volt battery, and 2 leads with a crocodile clip at one end and a banana plug at the other. Place the rail track on a level surface. Insert the ticker timer onto the end of the rail track. Place a piece of circular carbon paper onto the ticker timer. Connect the ticker timer to the battery by clipping one end of the wire onto the battery terminal and inserting the other end into the ticker timer, red to red and black to black. Measure out the ticker tape so that it is slightly longer than the length of the track. Place the trolley onto the track, making sure the clip is facing the ticker timer. Give the trolley a practice gentle thrust so that you can feel how hard you will need to push it to reach the end. Thread the ticker tape through the slots on the ticker timer, making sure it goes under the carbon paper, and then clip it onto the back of the trolley. Unravel the trailing end of the ticker tape so that it hangs in a straight line so that it will smoothly run through the timer. Switch the ticker timer to 40 Hz if it is not already set to this frequency. This means that 40 dots will be made in 1 second. Switch on the ticker timer and give the trolley a gentle thrust so that it will move along the track at a constant velocity. Remove the tape and place it on the table. Looking at the tape, count off the first 10 dots and cross them out as we will be ignoring them. Now mark off every 10th dot by drawing a line on the 10th dot. The space between the dots represent the displacement the trolley has undergone in 0.25 seconds. Measure the distance in centimeters between each set of 10 dots and write it on the ticker tape. Draw a table listing the time intervals against the distance travelled during each time interval, and then calculate the displacement for each time interval, which will be delta x. Now plot a graph of time versus displacement. This will show the graph for constant velocity. Part B. Investigating acceleration. Set up the rail track and ticker timer as before, but this time use a suitable support such as this can to elevate the track at an angle of about 30 degrees. Thread the ticker tape as before and attach it to the trolley, making sure to hold one end of the tape to prevent the trolley rolling down the track. It is not necessary to push the trolley in this experiment. When you are ready, start the timer and release the trolley, letting it run down under the force of gravity. Remove the tape as before and mark off every 10 dots, this time starting from the very first dot. Measure the distance in centimeters between each set of 10 dots and write it on the ticker tape. Draw a table listing the time intervals against the distance travelled during each time interval and calculate the acceleration for each time interval. Now plot a graph of time versus acceleration, and this will show the graph for constant acceleration. This presentation was brought to you by the Cape Town Science Centre, made possible by the sponsorship of the Western Cape Education Department.